minutes past the hour, so I think we'll go ahead and get started. Thanks everyone so much for joining us here today for the first edition of the HABs Collaborative and Cleveland Water Alliance's series on the state of HAB monitoring. This series is going to be a three-part series starting this month and running through October, dealing with a variety of topics around data and harmful algal blooms. This first session is going to be diving into the use of data from a management perspective from a variety of different folks, our panelists here today. Our next session will be tackling HAB data itself and the monitoring technologies around that. And the final session will be tackling nutrient monitoring technologies. So really happy to have you here with us today, and hope to see you in future sessions as well. Just did something weird. I'll just briefly introduce our panelists here today before we dive into the Q&A. I have a couple of questions for folks here, and then we should have time for Q&A from the audience at the end. Throughout the process, feel free to drop questions into the Q&A at the bottom of your screen. It is distinct from the chat, and we will go to the Q&A first. So if you drop your questions in the chat, we will hopefully get to them depending on how many questions we get, but please do try and drop them in the Q&A. I guess I should introduce myself. I'm serving as moderator here today. I'm Max Herzog, Deputy Director of Programs and Partnerships with Cleveland Water Alliance. It's my great pleasure to welcome 4 esteemed panelists to be part of the conversation today. Liz Cute is Senior Program Manager with Buffalo Niagara Waterkeeper. Jen Boheme is the CEO of the Great Lakes Observing System, GLOSS. Justin Chaffin is Research Coordinator at The Ohio State University and Ohio Sea Grant. And Breton Joldersma is Lake Huron Coordinator with Michigan Eagle. Thanks so much, everyone, for being here with us today. And I just want to dive in to talk a little bit about your work and how it pertains to this topic area. So I'm wondering if each of you could speak briefly to sort of how you use HABs data in your work, just as a way to kind of introduce us to your work and kind of the broader context of this area. And so I think we'll turn first to you, Justin.
Oh, yeah, hello, everybody. Thanks for having me, Max. So I work out at Stone Lab, the island campus at OSU. We use HABs data. Well, we collect data from the lake using grab samples, also deploying buoys and instruments, and we also do lab experiments where we'll collect water that has blooms or whatever's in that's whatever the phytoplankton assemblage is then. And we'll do lab experiments to try to understand why blooms grow, why do they produce toxins, what toxins are they producing. And with that information, combining the field data and the lab experiments data, we're hoping to inform models that can be developed to forecast microcystin concentrations, forecast bloom growth, and also bloom demise. These models then can ultimately be used for water treatment plant operators to get an early warning when toxic water is coming their way, beachgoers, managers, and all sorts of everyone who wants to use Lake Erie.
Thanks, Justin. Really helpful to dive a little bit into what this looks like in Lake Erie, which I think a lot of folks think about as the epicenter of these issues across the Great Lakes. But I'd love to turn now to you, Breton. I know you're engaging in some of this work over in Saginaw Bay, and would love to hear a bit about what that looks like and some of the collaborations you're engaged in there.
Yeah, for sure. Thanks for having me. I'm glad that I can be a part of this panel discussion and share some information about what we're doing in Saginaw Bay. I think Saginaw Bay is in a little bit different situation as Western Lake Erie Basin and all the research and monitoring that's been going on in that part of our Great Lakes. Saginaw Bay, a couple of years ago, probably 5 or 6 years ago, we pulled together a collaborative team to start to look at nutrient issues within Saginaw Bay. For those who aren't familiar with Saginaw Bay, it's the largest watershed in Michigan. It covers about 8,700 square miles. It's largely agricultural, and it has a history of some eutrophication-related issues, nuisance algal growth, and the deposition of decaying vegetation on the beach, what we refer to as muck. So we've had a lot of challenges with that over the past few years. And our team came together, like I said, about 5 or 6 years ago to look at what kind of nutrient data we had for Saginaw Bay. And so we pulled together a collaborative team, including folks from NOAA, USGS. We are working with Saginaw Valley State University, CAMU, Central Michigan University, local tribes, the Saginaw Chippewa tribe there in the Saginaw Bay area. And also TNC. And we came together to look at what kind of nutrient data we had so we could understand what was going on with nutrients in Saginaw Bay. And what we realized is we really didn't have a whole lot of data that was spatially and temporally accessible to us. And that we realized that there was a big data gap. And we needed to have an understanding of what was happening with nutrients in Saginaw Bay, both for the localized issues that we experienced with the muck on the beach, but also some of the dynamics with the larger lake. If you look at Lake Huron and Saginaw Bay, we do have some nearshore nutrient issues and eutrophication issues occurring. But then the offshore zone, we do have declining nutrients in the offshore zone. So we see both top-down and bottom-up pressures. And we do know that Saginaw Bay provides about 25 to 30% of the nutrients to the offshore zone. So our team came together to look at, realizing that we didn't have data. We came up with a strategy to, better get an understanding on what was going on with nutrient dynamics within the bay. And so over the past 5 years, we pulled together our plan and seeked out funding to implement a large-scale monitoring project within Saginaw Bay. Fortunately, we were able to get some funding about a year ago, so we're about a year into data collection. But as a part of this process, we were able to increase some nutrient monitoring across 18 different locations within Saginaw Bay, where we're collecting weekly grab samples throughout the year. So we're doing year-round sampling on the tributaries. We're doing that water quality sampling. We're pairing that up with USGS gauge stations so we can get discharge information and eventually calculate loadings into Saginaw Bay. We're also then pairing up the tributary monitoring with work in Saginaw Bay itself. So NOAA is collecting water quality samples in 10 locations within the bay. Both Saginaw Bay is kind of structured where we have an inner bay and an outer bay. So we have 5 locations within the inner portions of the bay and 5 locations within the outer bay. And so we're right now at a point where we are just starting to collect our data. We have about a year's worth of data that's starting to come in. And we realized that we need to collect a couple more years to start to understand what's happening with nutrients in the bay. So we're at a point in Saginaw Bay where we realized that we had a big data gap. And for us to understand what's happening with nutrients and HABs within Saginaw Bay, we needed to first start to have a robust data set to help us understand what was happening with nutrients and how that related to HABs in Saginaw Bay. And we're just kind of at that early stages of starting to collect that data. We do have other challenges that I think I'll discuss in a little bit with some of the other questions. But yeah, we're excited to be at this point where we're collecting data. I think we looked to some of the research and monitoring in Western Lake Erie Basin. We're kind of jealous of the long data sets that are there to help inform management and address some of the HABs issues in Western Lake Erie Basin. We're trying to set up something similar in Saginaw Bay. It is, one of the top 3 largest agricultural watersheds in the Great Lakes. I think the other 2 are Maumee and the Fox and the Saginaw. So we feel like this is a big kind of gap and we needed to start to collect the data to inform future management decisions.
Absolutely. And it sounds like you're laying a really solid foundation with the depth and breadth of collaborations across Indigenous groups, federal groups, state groups, local groups. That's really exciting to hear, and that combination of the nutrient HAB monitoring as well really plays at that intersection. I'm wondering now if we could shift, over to another geography in the eastern, basin of Lake Erie, as well as the Niagara River, and dive in with you, Liz, a little more deeply into what engaging with communities in this kind of work can look like, kind of that boots on the ground approach.
Absolutely. Yeah, thanks for inviting us into this panel. Excited to be here. Buffalo Niagara Waterkeeper, we're a nonprofit in Western New York, right? And we're working to protect and restore our water and surrounding ecosystems for current and future generations. And harmful algal bloom monitoring has really ramped up the last few years, but almost for a decade, we've been observing and making reports of smaller tributaries, smaller waterways, inland lakes in our region to the New York State Department of Environmental Conservation. They have a statewide mapping reporting system that we're feeding into and encouraging our volunteers, the public, to contribute that data as well. And we have been coordinating with some local partners and universities to assist our staff with some identification of the algae locally. What are we seeing in different waterways? We've been noticing a difference depending on which creek, which stream. And all this information that we've been gathering and gathering more and more every year is really been so useful for educational purposes to the public, to landowners, to municipal leaders, through phone calls, emails, social media posts that really take off because folks are concerned about safety for themselves and their pets and their children. And we've been able to really start some really important local conversations about water safety, future research and sampling needs, and improvements that some of these waterways really need, and queuing up potential projects down the line. And it's just been really exciting to see, real concern, and hopefully that's a good motivation for the future. And then we can, start to move into solutions. Western New York is unique in terms of we're on the eastern basin of Lake Erie. We haven't seen that lake-wide bloom over here yet. So we're really focusing in on those inland creeks, could be potential contributors to nutrients to the lake as a whole. And hopefully we don't have to worry about a lake bloom. That's our hope, but we're just, focusing more inland right now.
Absolutely. And I think hearing that perspective is incredibly important because obviously these big, impactful, see them from space blooms really, make the headlines. But I think how the majority of people that experience harmful algal blooms, it is in that like inland lake, stream and creek context. And so thinking about the work from that perspective is really helpful. Jen, we've heard here from our panelists so far about data collected by local watershed groups, research institutions, state and federal agencies, indigenous communities and agencies. There are a whole bunch of different stakeholders just in this group, that are pulling together data from a variety of sources here. And I know, GLOS inhabits this really interesting space at the Great Lakes level of integrating and serving up a lot of those data. I'm wondering if you could speak a little bit to, that role, and particularly how HABs and nutrient data, HABs relevant data, plays into that for
Sure, happy to. Thanks for having me. The Great Lakes Observing System is a freshwater regional association within the umbrella of the Integrated Ocean Observing System. We're the only freshwater region, and so we really tend to focus in on the particularities that are unique to the Great Lakes region. We're a nonprofit, and we provide end-to-end data services to support science, policy management, and industry in both the United States and Canada. So we have a broad scope across all 5 Great Lakes. Our mission is to equip all observers, including the public, with high quality lake information, whether they're venturing out on a boat or confronting harmful algal bloom impacts in their own communities. We do this by collecting information from a variety of platforms, assets, and sensors, in particular through funding and support of the National Harmful Algal Bloom Observing Network. So we are part of the national effort that includes the Salty Coast, who also have their own harmful algal bloom issues. Our particular monitoring approach includes Western Lake Erie as well as Green Bay and Lake Michigan, and we even have sites in Lake Superior. That's the fastest warming lake in the region, and it is starting to see the follow-on impacts from increased nutrient runoff and the harmful algal blooms that could potentially result from that runoff. If you're interested in real-time observing data, we offer the IU certified access point via Seagull, at seagull.gloss.org. And this last year, we have focused on improving the breadth of HABs data that's accessible right now on Seagull, as well as the visualization of that data. So if you go to Seagull, you'll get an example of a recent partnership that we had with the Cooperative Institute of Great Lakes Research to develop new features that allow us to ingest, manage, and visualize real-time data focused on the biomolecules of the toxins themselves. So that increases our ability to share the really critical information related to toxin production of different lakes. And these are still in the research phases. We don't have real-time toxin information yet. All of our toxin data is based on previous research events, but it is there and available for study and visualization. And it includes biomolecules like DNA, RNA, proteins, and metabolites. It allows you to visualize the molecules as well as the environmental parameters like temperature, that are related to the water close by and the relative abundance of plankton. So we're trying to bring together these different streams of data in a way that's useful for those who are trying to crack that nut of how do we get at that real-time information overall on toxins. And so that's something that we've been spending a lot of time on and are very interested to talk with others about approaches that they're taking to get at some of these challenges.
Thanks so much, Jen. That's really interesting to learn about, having worked with Gloss and even familiar with Gloss in the past. I'm certainly, think of y'all as this, real-time data platform. And so hearing about these other data sources that you're working with and working to integrate and working to get towards real time is really exciting to hear about. In general, from our panelists, we've heard, I think, a lot of different types of data that are being collected through different types of organizations that are targeting different end users for impact. And so I'm wondering if we can turn now to some of the challenges that limit the potential of that impact right now. What are the kind of current data gaps, implementation barriers, technical hurdles that are really impeding the scope or progress of data-driven HAB management at this point in time? And I think, Jen, you really teed us up well to dive in on that microsystem topic. And I think, Justin, you have some thoughts on this. So perhaps we can turn to you to talk about some of the barriers and gaps in that area.
Yeah, as Jen mentioned, the main toxins that we're concerned about in Lake Erie are microsystems. However, there's the only way to quantify microsystems in the water sample is to have a grab sample. And then at best, you can turn it around in 24 to 48 hours because you have to freeze, thaw the sample. And then the ELISA method, which is the current method used by most agencies, the data used by most agencies takes additional 4 to 5 hours. So, if you want to know what the microsystem concentration is at beach or at intake, wherever you want, you're not getting that data for a day or so down the road. And then if we're looking into developing forecast models, well, in order to just do a forecast model, we have to know what the concentrations are now, right? But at best, we're starting our forecast 2 days late, right? So getting there's some technology that we've looked at that hope to reduce that time. The results have been mostly mixed, so not too reliable yet. But yeah, the biggest thing is developing technologies that can quantify microsystems and not just microsystems, but also other toxins for other bodies of water or other bloom species. But if we can really minimize that time between sample collection to data, that will help our models, but also help human health.
Yeah, thanks, Wilson. I think that's really helpful to hear. And just thinking about, toxin analysis is one of those key frontiers for innovation here. That's always of interest to us at Cleveland Water Alliance, really focusing in on trying to accelerate the development of those new technologies and their path to market. I think one thing that I've only learned, engaging in this work with folks like y'all, is that toxicity of these blooms does not necessarily correlate to their presence or visibility. And so, a lot of folks tend to think of, if there's a bloom that I can see, that's the problem. But this toxin element is really like an underlying, concern,
And,
often invisible.
and also I want to quickly add is that microcystin concentration does not necessarily mean toxicity, because there's a bunch of different congeners of microcystins that have a wide range of toxicity. So, that's another issue, is which form of microcystins are out there.
Right. So a lot of layers to peel back to really get to that potential ecological and human health impact in terms of direct measurements and predictions. I'm wondering if we can turn from sort of looking at the open lake and these large scale blooms, their risks on beaches and drinking water intakes, to more of that, inland perspective, looking at the watershed. And Liz, if you could speak a little bit about what it's like to be a watershed group trying to address these issues and some of the challenges that you run into.
Yeah, definitely. So, unlike other groups, right, capacity and funding for this work is always an ongoing struggle. And, that's for both our organization. We work within a very large watershed, so responding to every bloom is difficult, even though we try our best. And the state agency, the DEC as well, right? It's a large state. They cannot make it out to every bloom. So locally, we are, the experts for our region, and we do a lot of public engagement and education and sampling, but it's limited. And we've been working hard to, collect as much data as we can and incorporate that into future, funding asks and things like that. And we also have some other challenges specific to a few different waterways. We have a creek in our watershed that's had an annual Euglena bloom for 5 years or more, for the duration of the summer and early fall. And while it's not cyanobacteria, it looks just like it with your bare eye. So folks are just used to it, and they kayak through it, and they've kind of almost become numb to it. They just expect it. So I have concerns of like, oh, they're used to that. They go to another waterway that looks like the bloom they've experienced, but it's a different species that might have toxins, and what the impact of that will be. So that's like a small kind of sub case that we have here, but very interesting. And that's why we're focusing on just trying to figure out what bloom is what species locally, and kind of strategies that we can form, and what other groups can we bring in, forming a technical advisory committee, and just, continuing to queue out the data gaps and the needs that we have. It's not a short list, unfortunately, but it's really interesting work, and folks are definitely tuned into it now more than ever, I think, as we just see more and more blooms every year, and they're extending longer into the fall, starting earlier in the spring. So yeah, definitely challenges, but we're encouraged by, the public's, response and interest in the issue and solutions.
Yeah, thanks, Liz. That's really helpful. I obviously, calling out that capacity challenge is something that'll translate across a couple of different, projects and areas of work. I think Brett will speak to that more in a moment as well. But I think you also hit on something interesting, which is, even though, Buffalo Niagara Waterkeeper's capacity is limited, you are still adding capacity that the state agency wouldn't be able to address by itself. And both in terms of monitoring and in terms of that community outreach, which obviously it's always an uphill battle. We can never collect as much data or talk to as many people as we want to. But I think it speaks to some of the value of local watershed organizations, volunteer water quality monitoring, that you can have these conversations and build out those networks as well. as I sort of alluded to, Breton, I know you have some thoughts about kind of sustainable operations of these networks and how you can really build out that funding base, coming from the perspective of really like a multi-agency, multi-institution collaboration. Sort of what is that looking like for you?
Yeah, for sure. We starting off when we first identified the fact that we had a large data gap and that we recognized the need to build that monitoring need. We definitely worked hard to pull together partners and identify, how would our data support multiple different programs across the federal and state and local agencies and fill the needs of multiple different stakeholders. Our work will hopefully be used and will eventually be used to help inform some of the targets set under the Great Lakes Water Quality Agreement. So from the perspective of Annex 4 of the Great Lakes Water Quality Agreement, we had targets that were carried over from the previous agreement. So dating back from, I think they were originally set, our targets that we're working under right now were set back in the early 80s before zebra mussels and quagga mussels came into the system. So we have questions right up front, like, is the current targets that are in the 2012 Great Lakes Water Quality Agreement even appropriate with the fact that the system has changed so much with the introductions of zebra mussels and quagga mussels? So when we started framing it, we set up our project to hopefully address that question. But there's also under the Water Quality Agreement, the AOC, the Saginaw Bay and River is an area of concern. The eutrophication beneficial use is considered impaired. And so we didn't really have much traction as a state and federal agencies on how to move forward with addressing the beneficial use impairment within the AOC. In addition, we are tying our project to other state priorities. About 2 years ago, the state did list portions of Inner Saginaw Bay as requiring the development of a total maximum daily load. So we need data to help inform the development of that program. And we also know that, there's a lot of work up in the watershed to install agricultural BMPs and to work with producers to address some of their nutrient issues. And so we're really setting our project up to be a source of information for multiple people to use. And in doing so, the Saginaw Bay Monitoring Consortium has developed a project dashboard, which is available. I did post it in the chat, but I think that the link only goes to the panel. So I don't know if Max or if Connor can copy that link to our dashboard and get it out there so everyone can see it. But our data will hopefully also be available to do cross-basin analysis and comparisons to see what's happening within Western Lake Erie Basin, looking at that data, and look at some of the unique differences between what's happening in West Lake Erie Basin, maybe Saginaw Bay. And hopefully having that data available will be beneficial to help gain some insights on what really triggers the toxic events. In Saginaw Bay, we do have some toxic events. We do get some microcystin that shows up, but it's not at the scale and level that we see in West Lake Erie Basin. And so I think having this, different data sets that people can access and use to evaluate what's happening with HABs could be very beneficial. We are too, the challenge of funding is real. We identified the data gap and it took us 5 to 6 years to actually get some funding to start monitoring. And so right now we're operating under I think we have about 3 to 4 years worth of funding available for this first phase. But we are already, even though we're 1 year in, we're starting to transition and think about how can we secure long-term funding? How do we adaptively manage our monitoring sites? We set up our program to hit a bunch of watersheds or a bunch of tributaries that really haven't been monitored in the past. So we could find out that there may not be major contributors. We may be able to scale back or change our approach to where we monitor. But the first step was we just need a broad, kind of robust monitoring effort to see what's going on, and then adaptively manage our monitoring efforts based on funding needs, based on what we're learning from the tribs and what that means for loadings into Saginaw Bay. And so we are going to be, over the years, managing our sites and adapting to what we learned from, these first couple of years of data collection. We have, really aligned our work too with Saginaw Valley State University. they've been a great partner, and they really do the tributary water quality monitoring. SPSU is also in an exciting point right now too, where they have a Saginaw Bay Environmental Science Institute. They are in the process. They just secured funding this past year or so to actually develop a new facility that's going to be right on the Saginaw River, right near the bay, where they're going to have a kind of a research education facility that's really targeted on environmental issues related to Saginaw Bay. So it's going to be an opportunity for us to engage with the public and educate them, but also help us kind of center some research around some of the issues facing Saginaw Bay. So we're trying to partner with a broad suite of people and agencies, and think about different ways we can find some long-term funding opportunities as well. And so we're going through that process right now. And I think over the next 2 to 3 years, we'll try to come up with some options for us to pursue. I know we've talked about, the possibility of looking at National Estuary Research Reserve Systems is an opportunity to get Saginaw Bay identified within that reserve system. But yeah, that's one idea out of many that we're looking at for trying to set up a longer term effort.
Yeah, that's really helpful, Brett, and thank you for walking us through that. It's exciting to see, from my perspective, the level of intentionality and breadth you're bringing to kind of identifying those target end users and end uses of the data to kind of build that funding relationship, at a variety of scales, thinking about, everything from the lamps to the community end use, and really trying to make the connections there strong so that there's funding to support what people see as valuable. I love too that you explored, that you're exploring the NAIR system. I think we're really fortunate in the Lake Erie Basin to benefit from Old Woman Creek National Estuarine Research Reserve. They've been a huge resource to us. And, in general, for us at Cleveland Water Alliance, building out sort of our sensor networks through the Smart Lake Erie Watershed and volunteer water quality monitoring through the Volunteer Science Network, we found that the way that each individual sensor almost becomes sustainable is if there is a drinking water treatment plant or a watershed manager that is getting value from that data specifically. And then that lets you sort of get those assets out there, get that data collected, whether it's a sensor or a volunteer, and then be able to, integrate it together and look at some of those bigger pictures and make adaptive management decisions. So that's really cool to hear sort of all the different angles you're exploring there. And I think that starts to really push towards, what is our strategy moving forward as the Great Lakes, really to build out the systems that we need to address some of these barriers. And so as, my last question to you all before we open it up to, our audience here today, I'm wondering if we can turn to sort of what the future of data-driven HAB management looks like from your perspective. What are the actions that are being taken to address some of these challenges that you laid out? And what is the ultimate impact you'd like to see from these systems and actions if we can, reach that future where we, envision the impact being as maximized and broad as possible. I think, Justin, I'd love to turn to you first to speak a little more from kind of that research and Western Lake Erie Basin perspective.
Well, to try to answer your last question first, I hope in the future these blooms are not as big. So we're just monitoring, at a baseline level to make sure they're not there. But in the meantime, when we're still having blooms and until reduced phosphorus and nitrogen loads actually happen, we need to be able to incorporate new tools, both from the remote sensing side all the way down to the molecular scale. We really need real-time data, toxins that are present, congeners that are present, understanding are there omics data we could look at that are indicative of blooms coming, toxins being produced, even before we can see the bloom. Are there markers out there that we could develop assays, quantify in real time, many sites throughout the lake, get real-time data so we can develop toxin forecasts. I think, the ultimate is getting real-time data, reliable real-time data, both at the large lake scale and then also down at the molecular scale, incorporating across the gradients of scales, spatial gradients and temporal gradients to really help understand the system, but then also forecast blooms and toxins.
Absolutely, yeah. A lot of frontiers for the technology and the science to push on, but some really incredible impacts that we'd see if we can get there. Hearing a bit about what could the new streams of real-time data look like and how can that drive prediction and action. I'm wondering if another big part of that is sort of the long-term data, the trend analysis, the historical elements, and how that can help us predict future impacts. I'm wondering, Breton, if you could speak a little bit to that, coming from this perspective of really trying to stand up a long-term monitoring network.
Yeah, I think, like you mentioned, our goal is to have that long-term data set. We realize that there's a lot of value in having that for us to understand what's happening with the system. I think as we continue to face the challenges of climate change and we see the impacts happening, being able to keep our finger on what's happening and making sure that we have good spatial and temporal distribution of data come in on Saginaw Bay will be critical for us to understand different impacts of the system, for us to understand how our management activities are hopefully improving what's happening within the system. And if it's not, it gives us the opportunity to adapt and manage appropriately. As I mentioned, I think in the previous question as well, some of the challenges that we do have is, think about long-term funding and how that fits into our long-term vision. And I think there is a role for new technologies to come in. I know, like even right now with our work to capture discharge information, for us to develop our reference curves for our different tribs, it takes about 3 years worth of data. And so while we're going through this process, it could be a good opportunity to test out new technology where we could pair new sensors and new technology with the old trusted methods of they're determining your reference curves and collecting data. And so that's something that we have been thinking about as a team that could help us adaptively manage the project with new technologies. Well, we do have some challenging tribs within our system where we do experience backflow. And so that is a challenge. You can't just expect that the flows are always going to be moving in one direction. So we do have backflows that occur with different wave, for instance, events. And so it makes it a challenge. But I do think, while we have a robust system and monitoring network set up, it's a good opportunity to explore opportunities with new technologies. And can we deploy things alongside the old techniques to get an understanding if there's correlations between what the new technology could provide versus what our old techniques are doing. So I think finding ways to incorporate new technologies will be very important for us. And yeah, I think that's kind of, I think those next phases is how do we incorporate new technology into our system? And the other thing too is making sure that data is available for other people to access and use for different research questions that different researchers might have. So our data is on our dashboard and it is downloadable. Right now we just have the tributary data available on our dashboard. And over the next few months, we hope to be able to incorporate NOAA's Bay data to that as well. So data will be there for researchers to be able to download and to look at and to use to address specific research questions that they may have.
Yeah, absolutely. I mean, I think that really advances this narrative of, the need for technological innovation, incorporation of new innovative techniques into monitoring programs, as well as I think, cementing some of the value of tried and true methods and how there's sort of this, synergy, hopefully, between long-term, very reliable data sets and the piloting and scaling up of new technologies. I think the last piece you touched on really moves greatly or smoothly to, the next piece, which is this idea of once the data is being collected, those trends are established, new technologies are deployed, how is it exposed to other folks, not just for the end use of the deployer, but in a way that it's findable, accessible, interoperable with other data systems and, reusable for other uses. And I think that dovetails really nicely into sort of from how I perceive the role of gloss in some of these conversations. So I'm wondering, Jen, if you could speak a little bit to, the future of data aggregation, integration, serving that up in data-driven HAB management.
Sure, happy to. I just start off by saying data sharing is fundamental to the GLOS identity and mission, and also to develop partnerships and cultivate relationships with new communities and support the improved HABs and observing and data related technologies as they develop in the region. We're at present moving forward with continued support for both our observations network and also our data sharing approaches, so communities have the opportunity to share a HABs app information quickly with each other, even down to individual person-to-person sharing. On the OBS side, we've supported grab sampling events in Lake Erie to identify bloom composition and toxin analysis. In the future, we would aim to evolve that approach beyond Lake Erie to other lakes and provide the lessons learned in Lake Erie on a broader scale. We'd like to spend time on sample collection design and data sharing questions as part of that effort, making sure that this data has a purpose for public users. 70% of our Seagull users are actually public users, and only 30% of them are data managers and researchers. So it's something that's we think is critical for expanding the reach of this data. We'd also like to use this effort to leverage satellite validation potential for the region and how model algorithms might be improved as a result of that those efforts. On the data side, I think GLOS's vision for growth in that area includes bringing our data, including the Seagull platform, to new communities of users, including underserved communities. That's going to require new data pipelines with other regions, new data structures, new data sets, and potentially data warehouses to encompass and distill things into usable pieces for whatever community is looking to engage with HABs data. We'd be also really interested in exploring new avenues for data accessibility, so mobile applications, web applications, API, those sorts of things. How can we improve our discovery tools and search functions? Artificial intelligence is opening up a big wide door, and we're hoping to be able to walk through that sooner rather than later. And as I said before, social sharing of data, how can we externally communicate these findings, especially with rapid evolution of a HABs data? If there's an active event, can we get to a point where people are able to talk to each other in real time? And it's not just the researchers and the managers, but also individuals who want to share this information within their own community. One final thing to note, and this goes back to items that have been mentioned previously about engaging with Indigenous communities. GLOS has supported developing an Indigenous Great Lakes network to talk about data sharing and data sovereignty issues. And so we are committed to continue work with tribes and First Nations on new data entry points that remove barriers to sharing of tribal and First Nations data, but also preserve the data integrity, privacy, and the cultural sensitivities that go along with those type of activities. So if there's any other questions, I'm happy to answer them.
Yeah, absolutely. I mean, I think that's where we're getting to now in the course of this panel. Really appreciate everyone taking the time to answer my questions, but really want to turn it over now to you all, the audience, to bring your questions for our panelists. There's a lot of expertise in the room here from a lot of different perspectives. And so please do drop your questions in the Q&A so that we can respond to them. I see that we do have one question already in the chat, which is from John, asking for recommendations for remote sensing platforms for HABs and chlorophyll monitoring. I don't know if folks have tools in mind regarding this, but I will say, John, before we dive in, that this is a great topic to bring to also our next panel that will be taking place in September on, I believe, the 19th. And as part of this series, we'll be diving deeper into innovative HABs monitoring technologies. But in the meantime, panelists, are you at all looking at or playing around with or implementing any remote sensing platforms that interact with with HABs and chlorophyll?
Off the top of my head, I would point folks who aren't already aware to the NOAA Coastal Science website for their Lake Erie harmful algal bloom forecast, which includes basin-wide projections that are in part based on that type of data. I'm going to drop that link in the chat. That's ongoing work that NOAA has supported in the region, and so I'd encourage folks to look there as a starting point if they're not already interacting with that space.
Thanks, Jen. Our next question is from an anonymous attendee asking, do we have data on HABs invasive species in various states? And how do we monitor these species? Interesting question. My understanding, at least, is that a lot of our HABs are native. They're just not properly ecologically regulated. But I'm wondering if you all have much more knowledge than me, if you have perspective on this question of invasive HAB species.
Yeah, I'll answer that. Most of the cyanobacteria blooms that we have in our region are native. Splendospermopsis is a non-native one. And then there's some debate whether if Lingbia on the bottom is also native or non-native. And also, just to clarify, both those genera that I mentioned have new names as of this past couple of years, but Splendospermopsis and potentially Lingbia are non-native ones.
And do those non-native species require additional consideration? Or are they monitored in a different way, or bring different kinds of concerns versus native HAB species?
They would. I mean, that's a really big question you could ask.
Sure.
But the Splendospermopsis does produce different types of toxins. So if you see the bloom there, it may not be producing microcystins, it might be producing saxitoxins. And then the Lingbia on the bottom, still unclear of what toxins it does produce. It does produce some things, but they might be a lower toxicity version, but they also can produce some skin irritation things. But then if they rip up, they can also clog filters of intake. So it's a whole different conversation to monitoring what blooms that occur in the water column versus blooms on the bottom. So blooms on the bottom are a different can of worms.
Sure. Thanks, Justin. We have a question here from James asking if there's a quick, easy, and accurate method to measure HABs biomass. We need to ground truth our HABs models in the Great Lakes and other aquatic ecosystems, or we need this to ground truth. Again, James, would definitely encourage you to attend our session next month on other HABs monitoring technologies, but would love to turn to the panel if you have any insights on quick, easy, and accurate methods to measure HABs biomass.
I would add the fluoro probe is good. I'm an advocate of the fluoro probe. It'll give you chlorophyll A associated with cyanobacteria and other groups of algae, but there can be some differences amongst, especially at the lower ranges. They might get some misinterpretation. But if you're comparing relatively clear water to super green water, and in between, the fluoro probe does a good job at that.
Thanks, Justin. Other questions for the audience, feel free to drop them here in the chat. Questions about monitoring, questions about use of data, building partnerships, managing data, serving it up to end users. As we're waiting to see if other audience questions come in, I do have a question that I can bring to panelists who want to answer. I'm curious if in your experience, working with these data and taking management actions, interacting with end users, if you've seen, a win that really sank in, with you of like, wow, what we're doing is really having impact this data that we collected informed an action that's really helping people, helping the ecosystem, helping the economy, whatever it may be, or even if it's just, it's helping us understand the dynamics of these issues in a new kind of an exciting way. Would love to just sort of hear those success stories if anyone has one that comes to mind.
Well, I would say a success story is the heightened awareness of blooms. So that's not specific to anybody on this panel, but it's the community of HABs, folks, researchers, academics, agencies, some private groups, all coming together to leverage our efforts and coordinate.
Yeah, I guess I'm just going to add, I think a success that we're seeing so far with our Saginaw Bay Monitoring Consortium is the developing of those relationships and the partnership across the federal, state, local, tribal entities, and all trying to work together in the same direction. So, each group has their own expertise and they may have their particular end use. We're working with Michigan Department of Ag and Rural Development. They're a part of our team. So, as they engage with the different conservation districts and work with installing and implementing BMPs, they have their voice being heard. And so that collaboration is something that I think, already see as a success so far. I think some of our other successes are going to come down the road a little bit. Once we have a few years worth of data, we will be going through a similar process, which was done for Western Lake Erie Basin, where we develop kind of response curves and do a full kind of analysis of different endpoints to try to understand what kind of targets we should have for Saginaw Bay. And once we have those targets, that can help us track implementation, see how we're making progress towards those goals, and to assess and reevaluate our activities. So some of our successes are going to come down the road once we actually get a chance to assess the Great Lakes Water Quality Agreement targets and, if need be, update those targets. And that will hopefully give us a framework to start to understand where we're at with trying to address HAB issues in Saginaw Bay and help us kind of move forward in a collaborative process. So everyone has an understanding of what our kind of end goals potentially are, and we can start to work together as a collaborative stakeholder group to address those issues.
Absolutely. I mean, Breton, I think in my mind, your comments and points dovetail with what Justin's saying, which is that, some of our successes really are setting the stage for long-term success. And those kinds of partnerships and broader public awareness are what's required to really make these monitoring and action networks sustainable. And so I think, we can certainly count those as wins, even if there are still blooms, in our lakes and streams. Any other thoughts folks want to share on this topic or otherwise, or this question or otherwise? Okay, excellent. Well, we don't have any other audience questions at this point, so I'd love to just take this opportunity to thank again our panelists for taking the time to be here, share your stories, share your work, and for the great work that you're doing in this area. Really encourage all of our attendees to seek out more information about our panelists. We'll be sharing sort of a recap of this as well as the recording. If you want to learn more or potentially collaborate with them and their organizations. Also want to plug one more time that this is an ongoing series. Our next session will be on September 19th, focused on the technology side of things for HAB monitoring. And then our last session in this partnership between Cleveland Water Alliance and Great Lakes Commission's Great Lakes HABs Collaborative will be on October 17th, which will be focused on the technology side again, but from the perspective of nutrient monitoring. So with that, I'll thank our attendees as well for taking the time today. Thank you to the panelists, and I hope you all have a great rest of your day, great rest of your week.